Hello and welcome. This is Maths Athlete again. Today we'll be discussing gradient of a line, continuing on coordinate geometry. So, what is a gradient? A gradient is a measure of steepness. It's how fast you're rising. It's the rate of rising. And you can see it in such nature such as hills and mountains and so on. So let's look at a few examples. So here we have three positive gradient lines. All these lines have positive gradients because they travel from the left to the right. As you see, you can tell by a line whether it's positive or has a positive or negative gradient by if you look at the going from the left to the right, going from the bottom left to the top right. And so all these lines have a positive gradient. The only difference between them is the steepness. So this line would be the least steepest, and this would be the most steepest, and this would be somewhere in the middle. So let's write most steepest, and this would have this would be the least steepest. Why is it the least steepest and the most steepest? Because this is rising the slowest, and this is rising the quickest. This one is going up the fastest. And so this is an example of positive lines. As we're going to show now, there's negative. So here we have negative gradients. So this would have, so all these lines are traveling from the bottom right to the top left. So this is like exactly the opposite of positive ones. They act the exact opposite. So these are negative. And again, they follow the same characteristic. This would be the most steepest, and this would be the least steepest, and this would be somewhere in the middle. Least steepest. Excuse my handwriting. So this would be the least steepest. So yeah, so this has, so basically the steepest ones have the highest value gradient. Now there's three more examples. So these are the two other examples, the two next examples. So this is if you have a horizontal line. Any horizontal straight line has a gradient of 0 because you're not traveling a height. You're just staying at the same height. You're not rising, so there is no steepness in the line, and so it has a 0 gradient. And also these are parallel. The reason why these are equal as we have drawn these arrows is because they're parallel. These lines 1 and 2 are parallel to each other, and lines 3 and 4 are parallel to each other. They have the same gradient, so they're equal. They have equal gradients. So say say line 1 had a gradient of 2. For less complication, say line 1 has a gradient of 8, then line 2 will have a gradient of 8. But of course, if it had a gradient of 8, realistically, it would be more steep because it has a higher value. Similarly, if this had a gradient of minus 8, then this will also have a gradient of minus 8 as they're parallel. Parallel lines have the same gradient. That's a must remember. And as you can see here, it's demonstrated here as well. They're all gradient. They're all parallel to each other, and they all have a gradient of 0. Because they're not rising, there's no gradient. So if a teacher asks you, or if someone asks you, what is the gradient of a horizontal line, just say it's 0 because it's not rising. There's no steepness in it. You've never heard of a steep mountain. Sorry, you've never heard of a flat mountain. It's like an oxymoron, as you'd say. So the final example. So I wanted to keep this example for the last. Basically, you were thinking, we were talking about horizontal lines, but what about vertical lines? So here's the y-axis, here's the x-axis, and then here are the vertical lines. Now, this is a bit tricky. We'll have to show you, it will be explained later on in the video of why this is illegal. Some of you may have, they're like, oh, it's illegal, and what's illegal in maths? And you would straight away know the answer. But anyway, you will find out later. So anyway, let's go on to finding the gradient of straight lines algebraically. So here we have a plane grid. Let's write the axes in black, of course. Black. Okay, y, and this is x-axis. So let's find the gradient of, say, a line with, here is point B. I don't know why I'm starting with B first. Okay, I'm trying to get a nice example. So this would be point A. And we want to find out the gradient of this line. Now we know straight away that it's going to be positive because it's traveling from the bottom left to the top right. Okay, so now let's give it some coordinates. So algebraically, this would have coordinates x1, y1, and this would have coordinates x2, y2. Let's write the coordinates here. x1, that's not a comma, x1, y1, and this, and b has coordinates x2, y2. Now how would we find the gradient? The gradient is kind of straightforward. It's basically the change between, it's basically the change in the y coordinates divided by the change in the x coordinates. So the change here, as you can see, the change in the y coordinate was from y2 minus y1. This would be the change. This is also, so let's write this here, the change in y coordinate, which equals this. And similarly here, this is the change in x coordinates. This is the change in x coordinates, this is the change in the y coordinates. And as we know from the previous videos, that this is the same as distance. So as you know, this is the distance of, if we look at this as a triangle, this would be the distance horizontally, this would be the distance vertically, you know, the distance of the side. So to work out the gradient, to work out the speed of the rise, we would divide the change in y coordinates over the change in x coordinates. So it would be written as y2 minus y1 over x2 minus x1. And this would be our formula, as we always write them in green. So to work out the gradient, we'd use this formula to work out the speed of the rise. And now let's test this out on an example. Okay, so let's give an example. Let's give points for A and B. So A would have, let's give it basic again. It's positive, so we know the gradient is going to be positive. There's going to be no negative numbers involved, unless we want to be tricky and we want to go into the negative. We can if we want to. In next example. So let's give point B here. So A has coordinates 2, 2. In my previous videos, I always use this point here, 2, 2 for some reason, some odd reason. Okay, and this would be 8, 8. And so let's work out the gradient let's work out the gradient of this straight line here. Let's join the points up. Okay. So, working it out, we'll use the equation y2 minus y1 over x, that's a terrible x, x2 minus x1, which is, it's going to be a very simple mass, 8 minus 2, because this is x2, y2 and y1, and a minus 2 again. Sorry for the simple equation. So it'll be 6 over 6, and so the gradient is 1. So as you notice this graphically, you notice that as you go up by 1, you also travel by 1. You travel across by 1. So as you go up, you travel across by 1. So if we view this, so if we wanted to work backwards and we wanted the gradient of 2, we'd say to ourselves, okay, we want to travel up. We want to travel twice as much up as we travel across. So we'd use a line. I'm going to draw the line in blue. It doesn't really matter if we're in the negative section, as long as we're traveling from left to right. So I want a line. I want a straight line with a gradient of 2. So we would try and make it so we go up twice and we go across once. And as shown here, so okay, the line changes color. Okay, so we went up 1. Let me put it on the pencil. We went up 1, 2, and then we went across 1, and so it would equal to a change in y would have been 2, and the change in x would have been 1, because we went from here to here, so that would be 2 going up and went 1 across, and so the gradient would be 2. 2 over 1 equals 2. Okay, and similarly, if we want the gradient of a half, we would travel half the way up with y, and 1 along across with x. Okay. Yeah, so basically this is how you calculate the gradients of a straight line. I say straight line because the word line can actually represent curves as well. In maths, the word line represents curves. So whenever a person asks you, work out the gradient of a line, do you mean a curve or do you mean a straight line? Because a curve is when you introduce into differentiation. And this is where you start seeing dy over dx. So if you were hoping, what does dy by dx mean? It just means delta y over delta x, and delta means change. So change in y. You can say y coordinate if you want, over change in x. And also they use the triangles. They used the triangle delta and delta x. And so if anyone ever asks you what does this mean, this just means you're calculating the gradient. Calculate the gradient of a curve, of a straight line, and so on. And this would be the last. So let's add one more example. Let's use negative gradients. I was going to end the video, but let's just do a negative gradient example. So we'll have a negative gradient here. I'm trying to make it perfect. You want the points to join up. So this has a gradient of 2. Straight away we can see, like in our heads, we can calculate it. We went 2 up, we went 2 up, and we went 1 across. But as we calculate, because it's a negative gradient, we'll always have as negative. So this will have gradient of negative minus 2. This is positive, this is negative. And later on, if we want, we can discuss the opposite. What is it? Perpendicular gradients. So say we had a gradient. Say we had a line with a gradient of this is exactly 1. What would be the negative gradient? What would it look like? Well, it would have the gradient would be negative 1. Actually, you know what? Let me say this for the next video. Anyway, thank you for watching. If you find these videos useful, please subscribe. I tried doing this video before, and the editing kind of messed up. So if it seems like I'm in a rush, apologies for that. Thank you for watching. Please give your ratings. Like this video if it was useful. Hey, once again, sorry. I kind of forgot to mention why it was illegal. As I mentioned before, the editing kind of messed up. Anyway, so say we had a vertical line here, and we tried using this formula. So it has. So let's give it some coordinates. So this is B, and this is A. It has points -9 and -8. And this has coordinates also -9 and where is it? 8. Yeah, okay, that was kind of perfect. Okay, so say we tried working out the gradient of it. So using this equation, we would use y2 minus y1 over x2 minus x1, and so y2 here would be -9 no, sorry, using the wrong numbers. -8, because that's y2 -8 again. So minus the the y2 here minus the positive 8 here. So this would be minus 8 minus 8 over negative 9 negative minus negative 9. Now, as we know, if we simplify this, let's move on here. This would become negative 16 over 9. A negative, negative and a negative make a positive, so 9 plus 9, which equals minus 16 over 0. And why I say it's illegal, because we never divide by 0. You know, mathematicians hate when people say, not hate, but they would be like surprised if you ever said, oh, divide by 0, because that's impossible, and why would you even suggest such a thing? So anyway, that's why vertical lines don't have a gradient, and they will never ask you to find the gradient of a vertical line. Also, you might have thought that through inspection you can actually work out the gradient, but if you were given a line, if you're given a line like this, and it doesn't really have, you know, you can't really work out a triangle for it, but you have the coordinates, you can just plug the coordinates in and you can get the answer. So say, let's write this. If I had a clearer, and so as I was saying, I just had to make some space. So say we had a I don't know, some line like this, and we couldn't really work out the gradient through inspection, and say B had coordinates. I always start with B for some reason. A had coordinates minus 6.5 minus 6.5 again, and this had a gradient of, say, can't, yeah, sorry, 8.5. I'll just say 8.5. I just want to write simplest. I don't want too many decimals. And you have 9.5 here. So say we had these two. Now you would be able to work out the gradient using this formula, but if you didn't, if you tried working out through inspection, you'd have to work out where does this line meet at the intersections. So you would look at points like this, and you would try work out where's the next point on the line, and you try work at the gradient. But this way it's quicker and more reliable in case there's printing, I don't know, there's something wrong with the printing. But anyway, this is how examiners want you to work it out. So y2, which is 9.5, minus y1, which is minus 6.5, over x2, which is 8.5, minus 6.5. And so this will become positive and this will become positive, because minus and minus, and you'll get some gradient. But anyway, this is why we have this formula, and we don't always rely on inspection. Anyway, thank you for watching, and goodbye.